My name is Roman Steva, and I currently work as a tech lead at a company called Melbourne, where we build brand new internet banking in ReasonML and React. And today I want to talk about our experience and also kind of like this is not a go write your apps in Reason talk. This is more like this is why I think Reason is better for your VM apps. But I was also thinking how to approach this kind of topic. So it's gonna be kind of like half of the talk is gonna be a story of me, how I got to Reason, and the other half will be like what is Reason about, and yeah, we'll see how it goes. If you have any questions during the talk, just don't hesitate to raise your hand or ask. I actually prefer it to be more like a discussion rather than talk itself. So how I got to development was like I started doing C. That was my first language, and C was really nice because it was fast. It was fast, but it would take kind of big effort to build anything bigger in C, right? And I mean, is there anyone who used to C here? Like, it's kind of like pain in the ass at the same time, you know. You have to manage your own memory. It doesn't have a garbage collection and so on. Well, so then I moved to C#. And this was quite nice because, I mean, at the time, C# we had this like Visual Studio where you had like a canvas in the center, and on the left side you had like a set of components that you could pick up from. And then if you like just drag and drop the component onto the canvas, and then you could just set some properties of that component, which is like React does it, right? And then we did some ASP with it and stuff like that. But I thought to myself, like, okay, since I know C, I could probably learn some PHP, and I started doing like e-commerce stuff. And this is like, I was still like doing like this backend work, and at some point I built my like, I don't know, custom framework in PHP and built like a couple of e-commerce shops. And then I decided I kind of want my e-shops to be more interactive, so I started adding more JavaScript to it and jQuery and Ajax stuff to it. So then I decided I want to learn how to make my apps even more interactive. So I kind of dove into JavaScript, and I moved to London. And at London, I kind of wanted to utilize my skills in PHP and JavaScript because I felt very strong there. I mean, like not in JavaScript yet, but like PHP. And I also wanted to find a company where I would learn more of that interactivity of like JavaScript. So I went to work for a startup called Instagram, which is they are not called that way anymore because Instagram was complaining about our name, but so they kind of like changed the name. But we were building like Instagram slideshows for like different events. I have like a video here where this is like a canvas and it's built with HTML, CSS, and JavaScript, and this is like just one of the slideshows for like Ferrari when they were introducing their new car. People were like taking photos of themselves, and then they could tag it with a hashtag, and we could immediately like show it on the screen, so people kind of like the product. So we shifted even to like do these for weddings and stuff, and or like O2 Arena, and then there was like even more stuff like WebGL kind of thing where I was combining, and this is whatever, like there was like a ton of slideshows, and they were all different. There were even some in Flash back then because this is like year 2013 or so. And then I was like, okay, so this is all
I was like the first developer there, but they already had something built there. So they used jQuery for everything. Like there was like a ton of jQuery. I was like, okay, this is not me very like progressing in this JavaScript, you know, journey that I actually was dreaming about. So I was like, okay, I need to change these slideshows to something else. And so back then, what was very popular was obviously Angular, right? So there was no React. Like this is like at the beginning of 2013, and like late 2013, like React came actually, and React came with something that looked like this, and everybody was like, holy crap, what is this? Like, why are you combining templates with my, you know, JavaScript logic? And everybody was kind of like, it felt like the world would split in half, you know, and then like, just get over it, and it's like, it's the component system of React. By the way, this is called JSX. Does everybody here do React? Do you guys, who does React here? Okay. So like React is super awesome with for building UI applications, and it's because this is like a shorthand syntax for a constructor. Instead of like writing constructors, you would just write JSX, and JSX is actually inspired by a language called XHP, which is the same thing for PHP, and it was invented at Facebook as well. Basically, it looks just the same. And but what was like troublesome at the point was because I was coming from the C# kind of, you know, C# kind of world where you have like everything is an object. You can't have just a function. Like whenever you want to have a function, there has to be an object holding its hand. You know, that's how they call it. And like you just can't write a single function because it's not a JavaScript is nice because it has first class functions. In the C# world, I kind of learned these, like I was learning about these design patterns, like you know, dependency injection and like services and like those object design patterns basically. And it was quite at that time there was no Babel, so it was painful to create services and objects in JavaScript. It was like, you know, everybody had to know how the scope works, and closures, and this and whatnot. So we were writing. So I was still at the company where we were building these slideshows. I just like shifted from the Angular kind of thing to more React, and every new slideshow was built in React, and I was using CoffeeScript for it because I was still used to this like object-oriented paradigm. And it kind of worked, but there was a day where I went for a meetup, and I heard about this new company called like Red Badger, where I immediately sent them my CV, and I wanted to work there. So eventually I was lucky, and they accepted me. But I didn't even realize I was like working on one of their projects, and I didn't even realize I'm writing LiveScript, which is like something like CoffeeScript, but a bit different. LiveScript is a bit better in a way that it's more functional. And at that time, I started learning about these like functional paradigms instead, because like the owner of the company was very like, he says that, hey, I just wasted my 20 years in OO shit, he says, instead of OOP. So let's go functional. And so I was working at Tesco back then, like building these another e-commerce stuff, like on a bigger scale of it. This is like, again, still LiveScript, but you can see these pipes. Every modern language actually has these, so it's quite nice to write code like this. So you read it like from top to bottom instead of like wrapping every function call in another function call. But then Babel came out, and Babel was like a game changer, right? let me just, I'm getting a bit dry. So Babel was like, when Babel came out, we had to like convert all our live script back to JavaScript, right? Because like it allowed us to write new JavaScript code and compile it back to the old one. And that was a game changer. So this is still like, and this is also when React came with class components. This is like version 0.13, and it used to be called 6.5 before Babel. Then it got its name, and then and this is where it actually this is where it breaks like chronologically. This is like then React came with like functional components, so you could write just functions. That's like React 0.15, I think, and then we had flow type. So we started implementing flow type into our code base, and that was like when, okay, now we have types in JavaScript. That's really nice. And flow is actually very sound when you use flow. There was a problem at Facebook. They had so they kind of like gave up on flow type from the outside world, but they were actually solving their own problems like internally because like they have so many files. It was taking too long to run this type checker across their code base. So it felt like flow type is dead, but now it's actually progressing again. But between that time, everybody shifted to TypeScript, right? Which was great. Like when we shifted, like at the previous company I worked for, we had flow type, and then we shifted to TypeScript. One of the interesting things was that flow type is actually written in OCaml, which is Reason. We'll get to that. But flow type is written in OCaml, and it kind of reuses its type inference. So by us shifting to TypeScript, we ended up writing more types just to keep our app safe. If you know what I mean, like we had types, but we had to add some more in order to keep it safe. Then React came with hooks, and that was actually this year or last year, I don't even know. And then TypeScript with hooks, and like you see, you had like a function which receives props, but you have to type those props, and then you're kind of safe. Yeah. And then I was working in TypeScript in the previous company, but I was like during the day I was doing TypeScript, during the night I was looking at Reason. So I was like during the night I was looking at this mainly like it's just like kind of more concise example, but you can see that there's no types whatsoever, but the code is 100% type checked and safe. So I want to talk about like why React, like what is React, like if it's changing so much, like what it actually is. If it's not JSX, so what it is. Like well, nowadays React is the most popular library for building UI applications. And I would argue that React is more like a set of principles rather than a framework, because it actually, like when you look at like the code, I mean like the library React, it's not like a framework, it's still like a library, just like managing your UI state. Like, so you can write it very declaratively, and you still have to kind of like handle the logic and how you like connect those components together. You have to do that on your own. So I want to talk about a little bit more about the React principles. 63% of JavaScript developers are using React. So this is from the survey of I don't know, NPM survey last year. Let's look at the principles there. So the first one, obviously, is composition. Like React is the key feature of React is composition of components. For example, it should be possible to introduce some local state to a component without having to change anything else in your application. Like Or like the other one is immutability. So like immutability is like another important design decision where it actually simplifies your reasoning about your application. Like if you're looking at a variable that cannot be changed, it's obviously easier to reason about it when, like, on the contrary side, you would have someone, changing it. You have this like mutations with like object-oriented languages where, like, for example, like in my spare time, I sometimes do like game development, which is very object-oriented, and like you're kind of mutating state on the other side, and you never know in what state the application is, because like you don't know where it got mutated along the way. So like immutability is very helpful with this. The other one is developer experience. Actually, let me come back to the immutability one. Like there's a problem in JavaScript where if you imagine you could class an array to a component as a prop, but array in JavaScript is mutable, and you don't know if someone mutated it along the way again before the render. If you have something else touching that state, there is nothing stopping you from changing that state before it gets rendered. And that's why well, I'll get to it, but like this is not very reactive, but stuff. And the developer experience, like that's like stuff like having React DevTools or yeah, I forgot what I wanted to say about this one, but providing a developer experience is obviously important to the React team. Then there is some other principles like common abstraction. For example, React. I still don't know why it's called React when it's not reactive. It doesn't tell you like how you build your applications. You can build it reactively, or you can build it. It's more like a scheduler. If you think about it, like it's running a schedule every now and then to see like what's changed. If you call a set state, that doesn't necessarily trigger a new render. It's still running its own scheduler that like checks for the changes. But also it doesn't force you to write your. Even though like you probably heard that like writing React applications is like functional. But like they don't force you to write your applications in a functional way. Like they don't care. It's just like here are your components, and this is like important decision as well. Like you don't wanna, because of this they have so much traction, right? Because like everybody can find what they like about it. And then even I would say even more important thing, like this is like important in any language. These are called escape hatches, which is like there can be escape hatches on a language level or in a framework. In terms of React, that would be the ref. Like it gives you the option to reach out to the DOM element. Actually, if you want to tweak it or do anything with it, you have the option. Like that's called an escape hatch. Then other one is like stability. React team always provided like code mods when they were like creating like major upgrades or like breaking changes. There were always some code mods and stuff. And last one is interoperability. So by that I mean like React is just a reconciler, but then you have platforms like React DOM, Free.js, React 3, or React Native. So those are the platforms that you can target with React, and that's very important as well. Like the interop should be easy. Why am I saying this? Actually, that's so you have two approaches to understanding of a React application, and the reason I was mentioning those principles is like they help you to reason about your application like in an easy way, rather than like I mean, those are the key concepts to keep your application easy to reason about. You have the first one. The first approach to understanding is through testing. By that, I mean, like you treat the thing as a black box. That's basically like what your QA is doing. He doesn't know how the code works. He doesn't have access to the code actually. You're just trying to figure out how the system works through testing. And that's not very interesting. Like the more interesting one is like inference reasoning. This is I don't know if it's the right term for it, but I found it somewhere. It's in a paper somewhere. And it's like this is attempting to understand the system by like examining it from the inside. The hope is that by using this extra information available, is like a more accurate understanding can be gained from this. And this is what I'm like focusing in this talk as well. The principles like composition, immutability, like common abstraction, they all help with this very much. So what is Reason? Reason is actually new, not a new language. Reason is just a syntax and toolchain on top of OCaml language. OCaml has been here for probably 2 decades now, and which means that it's basically like this systems language developed by some academians. So it has like 20 years of type theory in there, and it was also created by the author of React, by Jordan Walk. So here's a question for you. Does anyone know, because like React was created by Jordan Walk, he didn't actually create React in JavaScript at the first time. Does anyone know what language he used to create React? Does anyone know? Do you want to guess? No? The language is standard ML, which is another from the ML family languages, like ReasonML. It doesn't stand for machine learning, it's more like meta language. I'll get what that means later. It has, Reason has native support for JSX, so you don't need like anything like Babel to transpile your code, and it's just like built in. It has amazing developer productivity because it's like type driven. It's actually like whenever I'm developing a feature in Reason, like I'm kind of like I write the types at the beginning, and then it just like leads me to my destination somehow. You know, it's like and when I say I write types, it's very little of those types. They are more like domain types. I'll get to that. It has like pretty printer built in, like you know from Prettier. This is in Reason it's called reformat. It has those 20 years of type theory, which is why it's so good in inference. Because I really don't want to compare it to TypeScript, but there are some people who say the TypeScript has great inference. They probably didn't see the inference from OCaml, because that's on a whole new level. And it also follows those principles that we talk about, but it has it on a language level, because those principles are actually brought to JavaScript by React, and they still kind of live in those React applications. But like, for example, like composition, ReasonML has like first-class functions as well as JavaScript, and it also has like first-class modules, which is a bit more abstract concept. But we can, if you want to talk about this, maybe you can after the talk. Also, everything is immutable by default in Reason. If you want to have a mutable variable, you have to be explicit about it and wrap it in a ref. It's actually called ref, like a reference. And the developer experience is also very, but that's because like there's one feature that I haven't talked about. I'll get to it. Also has like escape hatches, like if you want to use something from the outside world. Does anyone know Elm here? Do Elm on database? No? Okay, so there was like recent. It's not very recent, it's actually like a year ago, they released like the last version of Elm, and so many companies dropped out from Elm, and they wrote some like a compiler that would take Elm code and compile it to Reason code, because like Elm actually removed their escape hatch, how to communicate to the outside world. So which is very important, right? Because for example, we are building this internet banking at my work, and you want to use the libraries that you know, for example, Next. So we are building on top of Next. We have like forming all those like JavaScript libraries that are actually tested. They have types in Typescript, and we can actually very easily write or even generate sometimes bindings for those packages and just use them. And so escape hatches are very important, because otherwise we would have to build our app as like we would do now, completely like from scratch. Like we couldn't use those packages. That would be ridiculous. We would never get anywhere. But like I was talking about like Reason, OCaml. So whenever I talk about Reason, you can think of like I'm talking about OCaml and vice versa. Also, there was like this standard ML thing that I mentioned that Jordan wrote. It's reacting. So these ML languages, they have like something in common, which is like super duper awesome type inference. Then they have like these first class functions, and the third one is algebraic data types and pattern matching, which is essential for like, well, I'll get to it. I'll get to what I mean by that. What else is there? Do you know, so is anyone writing hooks? I hope everyone is writing hooks if they do React application these days, because like, why not? And so hooks make everything easier, but there are some stupid rules about hooks, right? Like you can't have a hook, like you can't have a hook that's like conditional. Right? You can't wrap it in an if statement or like put it somewhere else. And the reason behind that is it's just a trade-off. Like it's just a design. But there's this. When I mentioned that with Reason, it's a systems language. You can target like platforms. So there is, for example, this project called Memory. It's like it's something like Flutter. If you know Flutter, it's basically it lets you write application and target web and native platform at the same time, or like a mobile. Now Reverie actually compiles down to mobile as well, so it's actually on the same level as Flutter. But I think the language is nicer. You know, it's like it's more pleasant to write Reason rather than Dart for me. But like, no offense. And then they actually use completely different rules of hooks. I mean, not different rules. It's just they don't have those stupid rules. You can use them conditionally, because like what they do is like you receive props, and then you receive the second argument. Like in React, you usually have just props, and then the second argument in Reverie is those hooks, and you have to return a tuple back, which is like the component and those new hooks that you updated. So that's basically how it works. But you don't write it, because in Reason you have something called PPX, which is like built-in playbook. So you only write those props, and it does the rest for you. I'll get to what that means at the end. But like, so who uses Reason? So this is Jordan, right? And if you don't follow this guy and doing React, like he's the best source for React stuff probably out there. So allmessenger.com that you are probably using every day is written in Reason. And I was talking to this guy, and I was like, he told me a very interesting thing. Like when they had flow type and JavaScript, and remember, flow type is still more sound than TypeScript. And when they had flow type, they had reported 10 bucks per day for messenger.com. And once they converted their whole messenger.com into Reason, it's now down to $10 per year, which is like $365. 56? No. Times less, right? I think that's important because like that's what the type system gives you. Here are some other companies that use OCaml or Reason, and what they use it for. There's this thing called Darklang at the bottom. If you haven't heard about Darklang, that's completely written in OCaml, and those are the guys who actually wrote the compiler from Elm to Reason. And they want to kind of simplify development by 100 times. What they mean by that is like they want to reduce the complexity, the accidental complexity, not the essential one, but yeah, whatever. I'll get to it. And here's like my favorite quote from OCaml. He's like he teaches OCaml basically, but it's what I was talking about when I said like you just define your types, and there are like two kind of, for me there are like two, as a developer there are like two kinds of types in Reason. Ones are they are abstract, and the second ones are like domain specific. Like they actually help me understand my domain, what I'm building. Like for example, when we have like an account in the internet banking, we could have like a flag, is closed, true or false, or we could have a flag. We could just have a property. They would have many different states, but they would be called like you probably know sometimes. It's called sometimes. It's like the status of the internet banking account could be just open or closed or like temporary. It's very easy to extend these kind of things rather than having booleans everywhere and whatnot. And now I'm getting to my favorite feature of Reason, which is like, here are some couple tweets that I found. People just love the refactoring story about Reason. That's the number one difference that people notice when they move from any other language to Reason, because it's just like you don't, because those types are abstract. You're just writing code. You change something somewhere and it tells you, oh yeah, you forgot to change this and this and this. You just follow the compiler. It tells you what else you need to update. And then this one is good. You can do it even drunk. And last one. So you refactor like 1,200 lines without a single runtime error. Like you don't even, while you're refactoring it, it actually doesn't compile. So when it compiles, it works. So you just edit like 1,200 lines and imagine that, and you hit a compile, it's green, and it works. So that's the story basically. That's the refactoring story. So what does it look like? This is like a React component, one of ours actually. It's like a target progress when you create like a savings account and you wanna shove some money into it. So you're like targeting your progress. But there are no types here. They're just like, this is just a function. This is just a function that has like an annotation at the top. The annotation is called PPX, I mentioned before. What it does is like, it takes your code and it generates something else for it. For example, what this annotation does is like, it converts this into a JavaScript that can be combined with your current JavaScript application. So you can just have some components written in React, some in Reason, whatever. Like you can combine it. And even if you add another annotation which is called gentype, I don't have an example here, but it would generate Typescript definitions or flow type definitions. Depends like what you are targeting. What the like if you want to one of those principles is like of React is to be able to introduce React into your application incrementally, and the same goes for Reason. But like incremental adoption and also like de-adoption is like an important thing. Other thing about this is there are no, I call it wall of imports. Like if you have a component that has some utility functions and whatnot, like it uses something, like for example this amount format, like it's a function on a module called amount format. I don't have to import it anywhere. Like, you know, it's just available because those are the like first class modules I mentioned before. They are available in the scope. So yeah, no wall of imports basically. And also like implicit return, there's no return keyword because everything in Reason is expression. No statements, so even like if is an expression, which just makes your code very concise and easy to read. And yeah, it's 100% type safe. So these are the ones that I call abstract types. You don't mention them, you don't know about them, but they are there. This is the output. This is not the output of that component. This is like on the left side we have Reason, on the right side we have JavaScript. What I want to like show in this slide is like basically it's a readable JS output. So if you need to like I don't know debug something, it's not it's actually easy. I'm not a fan of source maps because they are never 100% correct, but yeah. And it has some nice language features like pattern matching. And every modern language has this, like I don't know if you know Kotlin or some other language, they all have these, it's called pattern matching. It's just like, so these would be the domain types I mentioned. So it goes like abstract types and domain types. And then there are some generated types, which I'll get to later. But this is like a school person, teacher, director, student. And I can just pattern match and see like the student one is interesting, where I can pattern match an actual value of that student. So, which again makes my code very concise. If I want to write something like this in Typescript, I mean this is like, what is it, 8 lines of code with the space, or redundant? I don't know, whatever. So it's like 10 lines. If I want to write the same stuff in a type-safe manner, with the same type safety with Typescript, this is what I get. Like it's like that's like 30 lines of code. Like, but you get the same type safety. You have to create these like absurd functions that will never get called because this is called exhaustive checking. I didn't mention that if I add another value to that type, the compiler would break and say you forgot to handle this case here. Which is like, you know, potential runtime error for you. It just saves me from that. And if I want the same thing from TypeScript, this is how you do it. This is like, this is called discriminated union. It's a different approach, but it's very close. It's just like more code. But you can find this, I think they have it in their section of advanced types. And then you have the type safety as well. Anyway, this is an example of the same stuff, but with pure functional JavaScript. But like before we had flow type, back in Tesco we were experimenting with, or some other project actually. We were experimenting with this Fantasyland. I don't know if do you know Fantasyland, anyone? That's like a word. It's like a world where they say if you venture into this world, you're never quite the same yet, and it's kind of true because it teaches you a new way of thinking. I mean, even Reason it teaches you a new way of thinking, but that's probably that's why I think Reason is hard. I didn't mention this. Like, if you want to hear some. Like opinions why you shouldn't adopt Reason, then this is one of them. Like Reason is hard because it's like it has these new concepts. But this is basically the same that the one in Reason. Like you create a tag union called school person, which can be of those values, and the student has like a payload called name. And this is just JavaScript. That's probably like boring because it's not compile time check. It's just runtime check. It will let you know if you forget you know, the variant there. But let's go further. Now we have like functional composition. When you start writing your applications in more like functional way, where you actually combine functions and stuff, this becomes pain in the ass. Like so you kind of want the pipes I mentioned before, which Reason gives you. Like it's got this like fast pipe, and it has some other different pipe, but it's basically about like writing your code in a more readable way. And do you remember I mentioned this C at the beginning? That I like C because it was fast, and now we have, at the project I'm working on, we actually have some parts in Typescript written in. And it's big, that's why we have like Next there. Like, you know Next.js? Like it builds your handles the scaffolding and stuff. It's the slowest part in our like build. Seriously, like this is an example, like a video where I built like, I mean, we just started like 4 months ago, so we only have like probably something over 800 modules. But this is the build time when I'm building everything from scratch. And with Webpack, this probably, I don't know how. I mean, with Webpack, this definitely takes more time. What I mean is like, building Reason project is very fast. Like this took 8.3 seconds. And that was the build from scratch. Now I have here I have an incremental build time. Like I get like a, you know, tester of ours told me that, hey, I'm missing a test ID on this button. Would you add it? I was like, yeah, sure. So I'm going to add some test ID somewhere into my component so he can easily attach, you know, a insert to it or whatnot. And then I hit save, and it compass. I don't know if you see it, but it's like 141 microseconds, like milliseconds. So it's like 0.1 second. And yeah, like it's very fast. Like it's easy. The feedback loop is now, you know, faster, even on large projects. And this is this should play. I don't know why it doesn't. This is. Does anyone know GraphQL here? So GraphQL is this. I mean, that's probably the best thing that happened this decade. Maybe the last one. Is it 2019? Okay. Basically. If you're building type-safe React projects these days, you probably have TypeScript or Flow, and you use something like Apollo or Relay to Relay has its own compiler, and FlowType has Apollo has like a code generator which will read your queries and generate types for them. So you can then use them in your app, but you have to like annotate them correctly and whatnot. In Reason, I mentioned that there's something called PBX, which is a preprocessor. This is the example of it. This is another one. Like there was one that we saw with React component. This is another one called GraphQL. It's you give it a GraphQL query, and it compares it to the introspected server. I mean, it's instant because it's saved locally, like the introspection result. And it tells you like, okay, you're trying to use a field that doesn't exist on this element. You know, it'll tell you like doesn't exist in field user, and it'll give you back a module, which is like the assignment up there, like module sign up query. It'll give you back a module which you can then use in your code. And again, like this is actually the code down here. This is something. Yeah, you have a query up there, and then it tells you that you are using it differently. And then there's like, so there is no null in Reason. For example, that this happens a lot to us at work. Like sometimes backend developer changes their schema. So they change their schema. For example, the user can now have like a nullable, you know, middle name. but it wasn't nullable before, and because we have no nulls, we have to be explicit about handling our values, so it will immediately like screen, it won't compile our code. Like, the compiler will tell us, hey, this is now nullable, and you have to change it in order to compile the project, so you don't have, again, you won't have any runtime errors. And that's probably all from me today. If you want to know more about Reason, or you want to try it, we have a Reason Meetup Prague group where we sometimes do Reason hackathons. I mean, I wouldn't call them hackathons. It's more like no Reason experience is required for you. You can just come to us, and because you have usually we split you into groups, and like by 3 people, and the least experienced one is the one that codes. And the other ones are like telling you what to do, which is quite fun. And we usually build stuff like, I don't know, last time we did, the first one was a game of life, building game of life and targeting WebGL and OpenGL at the same time. You would compile it for both. That was a very interesting one. Or something in Reverie, like creating actually, a desktop app that boots like in milliseconds rather than seconds, like Electron, because like it's just native. It's just like it's 3 megs in size, and yeah, like if you want to know more, just like sign up for that group, or you can follow me on Twitter, where I tweet more usually about Reason and TypeScript stuff, and we are. And that's everything. Thank you for coming.